Hey everybody, just want to welcome you to week 2, module 2 for ME14, Mechanics of Solids course. So topics for this week, we'll be taking a look a little bit more detail at stress and strain, talking about some axial loading, and going through the modulus of elasticity, taking a look at a couple different examples of some tensile testing and how we can extract the modulus of elasticity from some of the stress strain curves from that data. Then we'll continue on with the second part of this module into the effects of temperature change and some statically indeterminate problems. Now, a couple of bookkeeping items. Quiz 2 has been posted to Blackboard. This will be due on Friday, the 12th by 4 p.m., just like all your quizzes are going to be due on Friday by 4 p.m. These are multiple choice through Blackboard. Homework 1 has also been assigned, so if you go back to your course schedule, you can see the schedule of when these homeworks will be assigned and due. This one's going to be assigned on the 8th, so it'll be released on Blackboard. You can go in through the assignment section. This will be due the following Monday by the end of the day at 11 p.m. So again, you're going to access these through Blackboard, and then you can submit your scanned copy of your solutions through Blackboard again before the due date. Now, just a reminder that I do have office hours scheduled on Wednesdays from 9:30 to 10:30 a.m. But if these times don't work for you, please reach out to me through a chat or on Teams or an email, and we can set up a time that works for both of us. So going into our second module here, we're going to be looking at stress, strain, and axial loading. So this module is going to consider the deformations occurring in structural components subjected to axial loading. So a couple things within this chapter that we're going to take a look at. We're going to introduce the concept of strain. We're going to discuss the relationship between stress and strain for different types of materials. We're also going to determine the deformation structural components under axial loading. We're also going to then take a look and introduce Hooke's law and how this relates with the modulus of elasticity. Discuss the concept of lateral strain and Poisson's ratio. We're going to continue on with axial deformations to solve indeterminate problems. And we're going to take a look at the St. Venant's principle and the distribution of stresses. Review stress concentrations and how they're going to be included in design. So this is kind of how this is going to start tying into some future courses like ME 171. Define the difference between elastic and plastic behavior, and this is something we can relate back to some of the stress strain curves as well, and do this through a discussion of such things as elastic limit, plastic deformation, and residual stresses. Then we're going to take a look at some specific topics related to fiber reinforced composite materials, fatigue, and multi-axial loading. So if we're talking about our textbook here, our reading guide, this will relate back to our textbook in Chapter 2, Sections 1 through 6. So as before, we're going to break down this module into a couple different lectures, a couple different sections. The first section being our Module 2.1. So within this module here, within this section, we're going to introduce the stress strains, take a look at normal strain under axial loading, stress strain diagrams, discuss those, relating them to modulus of elasticity, then get into the statically indeterminate problems and talk about some problems involving temperature change. Within this, we'll talk about a couple of key applications, some real life applications as well, relating to some of the research I've done with some tensile testing within various projects, talk about some of the key equations we're going to use and how those apply, and go through some problem solving steps. Now for the second section, for Module 2.2 here, we're going to get into a little bit more with Poisson's ratio, talk about some multi-axial loading and some generalized Hooke's law, and then we'll also get into some bulk modulus towards the end, and again, a couple of applications for these principles, take a look at the key equations, and apply some problem solving as well.